Hi viewers, this is the part 5 of dimensional formulae, and in first those who did not see 1, 2, 3, 4 parts, once you go through it and then see this part 5. In first 4 parts I explained the definitions of dimensions and dimensional formula and the applications where we can use dimensional formulae and where we can use the dimensional analysis. And in 5 applications we had seen, the first one, how do we derive the units of derived quantities? We can find the units of derived quantities. Secondly, we can convert units from one system to another system. Third one, we can derive the equations. Fourth one, we can check whether the equation is dimensionally correct or not. Fifth, we had also seen how do we derive the new relationship, that is E is equal to mc square, that we use in research in preliminary stages. So in basic idea we will get basic derivation. All these we had seen in first 4 parts, and in this we are going to see the limitations of dimensional analysis. Limitations means where we fail to use dimensional formula. First one, we can derive the dimensional formula of physical constants like Planck's constant, gravitational constant, but we cannot find their values. That is the first limitation. Second one, if the equation have more than 3 quantities like T is equal to 2 pi root of I by mgl. This formula you will learn when that chapter comes. No need of worrying about it. So if that contains more than 3 quantities, it will be difficult to derive such type of equations. Third one, if it has any physical constants, those also is difficult to derive the equations. And there are some equations, even though they contain 3 quantities, among them if 2 of them have the same dimensional formula, then it is not possible to derive such type of equations. For example, frequency of tuning fork, the formula for that is d by d means this thickness, length of the prong, velocity in this. So this is the formula for finding the frequency of the tuning fork. In this, the distance L is also distance only, D is also distance only. So both will have the same dimension formula. So such type of equations cannot be derived by using dimensional analysis. Next, if we know the quantity, we can find out its dimensional formula, but if we know the dimensional formula, we cannot identify the quantity, because two or more quantities may have the same dimensional formula. For example, work and energy both have the same dimensional formula, that is this. So if you know this quantity, we can find the dimensional formula, but if you know the dimension formula, we cannot identify the quantity. This is one limitation. Next, if the equations have non-algebraic functions like logarithmic functions, trigonometric functions, such type of equations also cannot be derived. For example, sound level, formula for sound level that you will learn in that chapter, not here. So, sound level I by I naught. Here, this contains a logarithmic function. So, such type of equations cannot be derived by using dimensional analysis. Now, lastly, in the fifth application, we have learned that dimensional analysis can be used to identify the new relations among the quantities. For example, E is equal to mc square. So, in preliminary stages, we use dimensional formulae for finding the relationship between the quantities. In this, we should know on what quantities this energy is depending on. Energy depends on mass and velocity of light in vacuum. This is the relationship between the mass and energy. Mass can be converted into energy and energy can be converted into mass. So, if you don't know on what quantities it depends, then it is not possible to find out the relationship among them. So, this is also one limitation. That's all about this video. I hope all of you like this. We'll meet again with a new video. Till then, I'm signing off.